problem. Tony and Guy live 76 kilometers apart. They decide to meet for a picnic. Tony leaves her house and walks at a steady pace of 6 kilometers per hour. 2 hours later, Guy leaves his house and walks at a steady pace of 4 kilometers per hour. Assuming they both walk in a straight line towards each other, how far away from Guy's house will Tony be when they meet? Alright guys, so again, not too dissimilar from the last one. It's time to get our pens out and start drawing. Just write everything down. So we've got Tony's house, we've got Guy's house. We know the distance between is 76 kilometers. We know the speed of Tony and Guy. Tony's speed being 6 and Guy's speed being 4. I'm also just going to write this equation up here as well. Speed equals distance over time. Now I always use S for distance. I know a lot of people probably use D, but I was taught S for space as opposed to distance. It's rather an irrelevant differentiation, but I've done it for so long now that it's really hard to retrain me out of it. I also quite like it, so there's that. I also use V for velocity as opposed to S for speed. I think that just makes more sense. Now I'm also just gonna, because I know we're gonna need it, just rearrange it into different forms as well. Okay, now the first part of the problem I think to solve is how Tony sets off 2 hours before Guy. So I think it's important to establish where he is, or she. Is Tony a guy or a girl? I don't know. Establish where they are before Guy sets off. So if Tony sets off 2 hours before, and we know that distance covered is V times T, they're walking at 6 kilometers an hour times 2, they're walking 12 kilometers an hour, right? So they have managed to get here, which is 76 minus 12, 64. So this distance is now 64 before Guy sets off. Right, now, there is definitely a quick way to do this, but I'm going to show you the long-winded way first, just because I assume that's how most people would solve it, and then I'll show you the relatively quick way. It's not cheating per se, but it's just a bit of a trick that in this situation specifically you can use. But yeah, like I said, we'll get the long way solved first. Now, since they're walking until both of them meet, and we have to find out where Tony is relative to Guy's house when they meet. They're both walking until they meet. So the time that each of them are walking for is the same, right? So if I put time of Tony's walking is equal to the time Guy's walking, I'm just going to call that T, right? That's going to be the same for both of them, okay? The other two variables are not going to be the same for both, right? Because we know that they're walking at different speeds, and if they're walking at the same time, then obviously the distance covered will be different. So I'm just going to put time equals distance covered by Tony over Tony's speed. Time equals distance covered by Guy's speed. Now we know each of their speeds, and we know these are equal to T, right? So we can now just set them equal to each other. So we've got the distance covered by Tony over their speed equals distance covered by Guy over their speed. So I'm now just going to rearrange this. We'll go 6 over 4 is equal to S of T over S over G. Right, so we have a ratio of how their distances match. We also know that since the distance between them is now 64 kilometers, for those two to meet, that distance will have to be entirely covered collectively between the two, right? Whether that's 1 kilometer from Guy and 63 from Tony, or whether they meet in the middle at 32 and done 32 each, the distance covered total by both of them has to equal 64, right? So if I now put S of t plus S of g equals 64, rearrange that, so t, and I'll just plug that in up here, we've got 6 over 4 equals S of t over S of g, which is 64 minus S of t. Rearrange this, so we've got, I might need my calculator here actually, 6 lots of 64 minus S of t equals 4 S of t. Ooh, what is this? That is 384? I might have to double check that, but I think it is. Minus 6 S of t equals 4 S of t. So you got 384 equals 10 st. So then you are left with 38.4 equals st. And that is in kilometers. Okay, right. So you know the distance is covered by Tony since Guy sets off up here. Which means you also need to find out where Guy is relative to his house, right? So you know Tony has done another 38.4 kilometers off of this 64, but where is that relative to Guy's house? So you do 64 minus 38.4, which equals 34 at 25.6. Ooh, 6. Will be clockwise here, sorry. 25.6 kilometers. Right, so that is how far Tony is from Guy's house when they meet. So we've successfully answered the problem, guys. Now, as you can see, that's actually quite a lot of work, unnecessarily, right? All of this, I say unnecessarily, it's probably not the case. All of this, which is quite a lot working out, I can do all of that in 2 lines. Now, let's move this so you can see what I'm going to do. Now, when you're faced with a problem like this, you can not cheat, but you can almost just take a massive shortcut. And I'm lazy, and I'm always looking for the quickest way to do it. So instead of, Tony moving towards Guy at 6 kilometers an hour and Guy moving towards Tony at 4 kilometers an hour, you can just imagine that Guy is standing still and Tony is moving towards Guy at 10 kilometers an hour. Because it's all about relative motion. And I don't want to get too deep into, frames of reference and Einstein's relativity, because quite frankly, I don't know what I'm talking about. But when you're dealing with a problem in which you can ignore everything else other than the object that you're dealing with, in this case, Tony and Guy, you can ignore everything else. So what I'm going to do is I'm just going to imagine that Guy isn't moving. Alright guys, so like I said, I'm going to use Tony's speed of 10, which I know from the previous equations is equal to the distance between the two, which was 64 over the time. So I know the time that they're both walking for is just 64 over 10, which is 6.4 hours. And since I want to work out how far they are from Guy's house, I'm going to use Guy's speed to work out the distance from his house or their house when they meet. So we've just got distance equals 6.4, which is the time, times their speed, which was 4, which equals 25.6 kilometers, which, if you double check, was exactly the same as what we got from method 1, except here I've had to do 3 equations, whereas previously I had to do 7 or 8. So yeah, there you go. I think it's 2 lessons here, to be honest. First one, when and where you can, try and cheat, use shortcuts in maths. And the second one, don't have friends who live super far away.